Hello dear students, welcome back to another video lesson. Today we are going to work about the topic defining of networks with OSI model grade 12 and page 30. Week number 9, lesson number 9, and your instructor is Muhammad Mustafa Bayat. So, most of the networking issues that we are going to study is about the concept that we should know the concept to establish a network. If we don't get it, the concept, we can't practically work it. So pay attention, be careful about the lessons that we are talking in here. You should learn it. In here we have defining networks with OSI model. First of all, what do you think? What's one OSI model? What does OSI mean? Maybe most of you be familiar with OSI model, but let's talk in a little bit in details in this very lesson. OSI model stands on open system intercommunication. Open system intercommunication. It reference to the model helps network engineers, network administrators, and system engineers define how data networking actually works. It means if we don't know the OSI model, how the data transfer, how we establish a network, we don't know. So because of this, it's important. From one computer to another computer, regardless of where the computer is or what software it runs. You should know the software, how the software runs network, how the software sends, how we use the devices in the network. You should be familiar with the networks. And here, be careful. This model is composed of 7 layers. It has 7 layers with each corresponding to devices, protocols, standards, and applications in real world. It means when you learn OSI, you should know that OSI works with devices, OSI works with protocols, OSI works with standards and applications. So, OSI is very important in here. And open system intercommunication or OSI reference model used to define how data communication occurs between the computers and networks. This model is divided into layers. It means 7 layers, as in previous slides I've told you. And each layer associated with each other, that we should understand the relation between these layers. The OSI model was created and ratified by International Organization for Standardization. I mean ISO. Most of the time we have heard it's ISO. We buy something because it's international organization for standardization. It should be standard for all over the world because we can communicate with the world. And it is represented in the United States by American National Standards Institute, ANSI. This model was created to do the following. It means this model, OSI model, is used to explain network communication between the host on LAN and WAN. How the computers on LAN are networking, they are transferring the data, or in WAN. OSI model explain present a categorization system for communication protocol suites. It present the protocols between each other, show how different protocol suites can communicate with each other. We will study. So this OSI model was created, has a set of 7 layers, we know, and each of these houses different protocols within one of several protocol suites. The most common, which is TCP or IP address, transfer control protocol and internet protocol. OSI model categorized how TCP or IP transaction occur. Most of the times we listen or hear TCP and IP. You know about the IP, but let's talk a little bit the TCP. TCP transactions occur, and it is invaluable when it comes to installing, configuring, maintaining, and especially troubleshooting networks. I mean, it's the work of TCP that how we can install network, how we configure a network, how we maintain network, and how we troubleshoot the network. Let's come and talk about the first layer. Layer 1, physical layer. And physical layer, this is a physical and electronic medium for data transfer. It means, if you see the OSI model in here, we have 7 layers: transmitting computer and receiving computer. Transmitting computer should send the data through 7 layers, and receiving layer should take the data, receive the data through 7 layers. I mean, 7 layers is necessary according to TCP. So first layer is physical layer, as you know, the physical part. Physical and electronical medium for data transfer. It includes, but it's not limited to, the cables. It's not limited to jacks and patch panels, punch blocks, hubs, MAUs. These layers, also known as physical planet. Concepts related to the physical layer include topology, analog versus digital encoding, bit synchronization, baseband versus broadband, multiplication, and serial, mean 5 voltage means logic data transfer. And here, if we talk about the layer 1 or physical layer, it's very important. In layer 1, in physical layer, we should consider that which topology we use: star, mesh, ring, bus topology, wedge topology, analog versus to digital encoding. How analog data translated into digital data. It's the work of physical layer. Bit synchronization, because the data, like this text, is converted into bits, 0 and 1s. Bit synchronization happens in physical layer, baseband versus broadband, and every bit has 5 voltage logic data transfer. I mean, the voltage for transferring is 5, and the physical layer makes this layer one of the easiest to understand. I mean, the units of measurement used this layer is bits. You should understand that this layer working on bits. Let's come on second layer. Physical layer is clear. That is, physically we consider the topologies. Everything data is converted from analog to digital, is measured with the bits. But let's come and talk about the data link layer. Data link layer. After the physical layer, we have data link layer. You can see data link layer. Data link. So what does data link do? This layer establishes, maintains, and decides how transfer is accomplished over the physical layer. Did you get it, the main idea? That this layer establishes, maintains, and decides how transfer is accomplished over the physical layer. It means it is the work of data link layer. How the data transfer? Devices that exist on data link layer devices are network interface cards and braces. I mean, you have studied about NIC, network interface cards, and also some of you will be familiar with the bridges. This layer also ensures error-free transmission over the physical layer and the LAN transmissions. I mean, this layer decides that how the data transfer over physical layer. Yes, exactly, physical layer transfer the data, but how? This is the job for data link layer. It does so through physical addresses. The hexadecimal address that is burned into the room of the NIC, network interface card. It has an address, I mean it is a IP address, otherwise known as MAC address. You're familiar with the MAC address. Every phone, every smartphone that you are using has a MAC address, and your computer that you're using joins to the network. It has an address to be discussed more later in this lesson. Okay, just about any device that makes a physical communication to a network and has the ability to move data is on the data link layer. It means, in simple word, data link decides how the data move on physical layer. That's that. Okay, and the measurements used in this layer is frames. Like, pretend that it's a frame. You watch a video, you can say cinema. I mean, this frame, this is called a frame. When there are, for example, frame 8, frame 9, frame 10, frame 10, 11. When these frames are showing very fast, it creates a video. So the data is collected, the bits are collected like the frames. And the last and the third layer for this video lesson is layer 3, about the network layer. If we are talking network layer, yes, network, this layer is dedicated to routing and switching information to different networks. How the data transferred through the different networks, it is the work of this layer. It means LANs. We are talking about LANs. What's LAN? We have studied too much about the LANs. Or inter-networks. This can be on a LAN or WAN, wide area network. Devices that exist on the network layer are routers and IP switches. When we created a practical lesson, on that practical lesson we created, if you remember, IP addresses for each switch and for each device. So these IP addresses, here we are getting into the logical addressing of the host instead of physical addressing. The address system of the computer is stored in the capturing system. For example, IP addresses like stored like MAC address. Now you can see that a typical computer will rarely have two addresses. One, a physical address, I mean hardware-based address, such as MAC address, in previous slide as I've explained it. And one, we have IP address or logical or software-based address. So we have two layers, and be careful about the measurement in here. The unit of measurement used in this layer is packets, because the frames are packed like a pocket. The frames are packed in network layer, and it creates packets and send the frames and data into the packets. Okay guys, thanks for your watching up to the end of this video. Don't forget to type your nice messages in box of YouTube channel, and subscribe the channel for the next videos.